So I think we're broadcasting. And this is probably where we're going to start. Okay. So last week, I think Thursday, we went through how this Pytorch setup works. I have all the files, I've tested it, so we're gonna run it, and then we're gonna change the network and rerun it. So let's get about doing this. So first we're gonna use Docker, which is interesting. I was just talking to someone and they said Docker actually has some security issues. So there's a few companies that can't even use Docker, or the IT department doesn't really let them use Docker, or how that works with Vitis AI, which basically the whole point is to use Docker. So we have a Docker here, so we're just going to run the Docker, and we're going to do CPU because I got no GPU on this little Linux computer I'm using right now. Yada yada yada. Oh yeah, yes. Say yes to all. Okay, now we're going to activate Pytorch. And activate Vitis. This other camera is just wobbling all over the place. I need to get a better mount. I'm sorry. The keyboard looks like it's just bouncing all over the place. Okay. So we're in Conda. So we're here, and we're just going to run the commands. I mean, this probably not going to be very entertaining, but I've added. I went through and added all the DCU 10, the KV260 references. The first thing we're going to do is train, and training's pretty generic, so train. Did I do this wrong? Let's find out. Yeah, activate that. Of course. Is there something in here? Oh, I gotta. Did we not activate Honda? Oh, I have to do that. Ugh, that's what we get for spelling. Okay, now we're doing the right thing. Now we can train. This doesn't take too terribly long. So we're training the network, and we're trying to see what happens. And we should go ahead and look at the files that I've edited for this situation. So, we want to look at quantize. This one matter? Instance. So yeah, this thing quantization doesn't even matter, right? Yeah, we don't care about the architecture at this point. Though this is quantization is using this right here, which is specific for Vitis AI, and that's where it does the quantization of the system and dumps it as a X model. So that's that, and then the target, I guess, is where we're referencing the. Oh, look at that! We finished with 98.98 accuracy. It's great. Um, yeah, we just added this device. And that's about it. Okay, cool. So we've trained it. Only 3 epics, but still pretty good accuracy. Now we're going to quantize calibration and then testing. I assume the calibration creates the use a little bit of a feedback loop to do the quantization to 8-bit values very quick. This is going to run quick. We want to look at the compile.sh that I had to do to get the KV260. So if we open with Notepad++, and just look at okay, sure. We just added the KV2 arch. So just another if statement for the compile.sh file, and that's really it. So exit all these. Now we're going to compile, but we're going to compile it for the KV260. KV260. We compiled the model, and then we're just going to target it. KV260, and this just kind of exports everything into the location. So we have compiled it. Now, if we go to the target KV260, there's a little bit of a problem. So if we vim into the app, the model, if we go down to, where is it? The main at the bottom. It's defaulting to ZCU 102, but you can change it in runtime, but I'm just going to change it now. To the KV260. Okay, cool. So we've generated Pytorch for the KV260. And the tutorial is very useful that you can just we can now just SFTP into it. So SFTP root 192.168.1.8. Boom. Yes, we'll continue. I already have it, but we can go ahead and copy. We can go ahead and put it over. I got cd dot target KV260, and this will push all the images. They already match, so I'm not sure if it's going to be the same thing or different. And then we'll run it on the device, and we'll look at the different threads. And yeah, and this is just a very simple network that's looking at handwritten symbols and is trying to, guess what number it's supposed to be. So if we now jump into this terminal is on the on the KV260. Nice little folder for it, and we can run the application with one thread. So this is our model. We got 3,000 frames per second, which is amazing. I mean, not super amazing, but does a good job. And if we change the threads to 2, we can see how the performance changes. And because the MP-SOC, the Kria, has 4 processors, 4 A53s, it's only, I don't think the performance is going to increase after 4 threads. I think 4 threads is going to be our max performance, and going above 4 threads is just going to overtax the processors, and just by there's no more support for more than 4 threads. Even then, 3 threads outperform the 4 threads, but we can try 5 threads. Okay, so yeah, 3 threads perform the best. So now what we're going to do here is we're going to go in and we're going to go to the common.py right here. So if we vim common.py, this is where the network's defined. And we have a very simple convolutional networks. So we have a 1 to 16 convolutional, normalization of 16 ReLU, 16 to 32, 32 to 64, and 64 to 10. So what we're going to do is we're going to double all the numbers besides 1 and 10. And what this is should greatly increase our network size. And it's not, effective networks are a lot bigger than this, right? So, I mean, we're dealing with probably 10,000 to 100,000 variables. This compared to GPT-3 and GPT-4, this is a very, very small network. Those ones are using trillions of coefficients, and these have a lot of coefficients as we split into 32 by 5, so it's 32 times 5 coefficients, 64 times 5 coefficients, 128 by 3 coefficients, and 10 by 3 coefficients. And that's how it kind of works. And we flatten it. So we're going to okay. Well, that's awkward. Seems that we have lost connection. Let's see. Log back in, I guess. So the system's working. Ah. Well, okay, so we have that file. I don't know what the guess we could kill PID 830 sudo. So if we, well, I guess yeah, it's in the container, so 830. See what happens if we kill 830, right? So sudo kill -9 830. Oh, so that container is not up and running. Ah, wow. I don't know what happened. Awkward. No, wrong one. When's this one? In here. So where were we? We were dimming common UI. Edit anyways. Oh. Okay. Let's try this again. Let's change our network size and see how the system takes it. We have our numbers from the previous system and we want to see how our network is affected. Okay. Or how long it's going to train this time. We did increase it dramatically. So we got like a 98.98% accuracy last time. So let's see if changing that changed anything. Also, 3 epics is kind of sad. I want to run like at least 10 epics. Let's see where the epics are defined in our system, right? Train, rate, epics. So we can just do dash epics. Do more than 3. 98.66. Still relatively high. Oh, look at it. We're getting better accuracy with our larger network. This is really good. Let's see what the last epic does, and then we'll transfer it over and see how increasing, do we increase it linearly? I mean, we doubled those coefficients. Yeah, you want to say we increased it linearly. Training probably takes longer, but operational wise, we probably just increased it linearly. 99.13. So we have better accuracy than before. So let's go ahead and do the quantization of all this stuff. Does anybody have any idea of networks to look at next? 99.11. Isn't that better? I mean, okay, slightly worse. I need to figure out a network to try next. 99.10. So great. I don't think we need to compile again, but we might as well. The KV260 and target KV260. And I think all we really need to do is transfer over that X model. I mean, it should be functionally the same. So we go ahead and CD into target KV260, and we have this X model, ls.la, and it is 209195 bytes, right? Figure out how to read human readable. Now, if we look here, we do ls.la, this one is 105305, so about half the size. So we created a twice as a 2 times larger neural network, and now we're just going to SFP and then add that. And then we're just going to put the CNN model. Okay, put the model. And now, so on three threads, we are getting 6137 frames per second. Now let's see with this new model how that changes. So our model is twice as big, going from 100k bytes to 200k bytes. Wow, that's interesting. The throughput didn't really change, even though we increased the coefficients. Let's see. Yeah, we'll just, I guess, run it one more time. So what you're telling me is it didn't really change the size, so we need to make it a lot bigger. Who's up for a 10x increase in size of coefficients? Let's make it from a 200k byte to a 2 megabyte thing. So let's go ahead and break it, right? We're gonna test the limits of this. So we're going to them common I. So we are not going to double it. We're going to multiply it by 10. So we're just going to add zeros to everything. And it's the best idea. But I want to see if there's a performance drop, right? Or how long it's going to take to train this thing. So 20 times larger than the previous network. I'm curious to see what happens. And then I have to go and play around with Pytorch, learn how to do other networks. in the same thing here and follow their kind of architecture. So I guess the next step for here is that we need to have a Pytorch example. Maybe I'll go Google some interesting Pytorch networks are just I know Pytorch already has I should just look at pre-trained Pytorch network. Stop moving camera. I should look at pre-trained Pytorch networks. Right? So we just go pre-trained Pytorch model. What Yeah, so I guess we're just gonna look for pre-trained on image nets. Pre-trained. Yeah, so yeah, let's just go ahead and try these pre-trained networks and see how they maybe pick a pre-trained network and then try to train it. Oh, that'll be fun. Okay. Okay, so we probably want to do a pre-trained network. We probably want to play around with different networks. Time to go read every single PyTorch AI tutorial out there, right? It's going to be so joyful. Should probably do a GitHub of all these examples. That sounds like so much fun. I think of other ways to make it interesting. Maybe try out the camera, have video outputs. YOLO would be fun. Do YOLO and PyTorch. Why don't we go over here and we hit top again? How are we doing here? Yeah, looks like you're using a lot of Python. Apparently 400% of the CPU. I assume I have a quad core or something to get 400% of CPU power. I hope this finishes in a timely fashion. Okay, so while that's running, we could resonant. I mean, they already did these examples, but we could do in PyTorch. I want to know the size, accuracies. How about large PyTorch model? Example, a large network. Learning PyTorch with examples. Yes, tensor autograde. Ah, yes. Yeah, I guess we'll just have to walk through different examples and then apply it to um, apply it to different networks. I did find an RF model that I do want to look at. I have to go figure out the usefulness of that. But yeah, I mean, what are some top PyTorch examples, right? Um, do, do, do. Yeah, I guess we could just generative adversarial networks, image classifications. We could go through these type of examples. We say projects, top PyTorch projects, projects. Okay, top projects to try out for image translation. We got and fully convolutional object detector, which eliminates recurrence detection such as yeah, this is some good things. Speech recognition. Yeah, those might be some fun ones. YOLO chatbot would be interesting. Top 10,000 PyTorch open source projects. Science, astronomy. Computer science. Whoa, 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 whoa. Oh, these are just awesome open source projects to begin with. This is interesting. Sure, I'll hit VHDL. What you got for me? Interesting. Okay, yeah, that's cool stuff to try. How are we doing here? We're still an epic one. I think I might have taken out the processor. So I guess maybe I just let this run overnight or something like that. We see what it does in the morning. That might be what we have to do. Okay. So I think we'll try to do a preloaded network next time. Maybe train it. Yeah, I don't know where to go from here. I feel like we need to find a database. I think I got a database, but I probably can't make a video with it. Yeah, I need to go find something to build, I guess, and to play around with. So, okay, well, I guess that's probably the video today since currently we're taking control of our processor. not been 40 minutes, but okay. So, I guess maybe we'll show off this tomorrow, look at some other networks or other projects, and move on from there. Thanks for joining me, and I will work on some other stuff. Finish one epic. Probably gonna take 30 more minutes. Yeah. Have a night.